official welcome to all of you. Thank you so much for joining us for today's virtual tour of the VLA and about Juneteenth. And we are super excited to share the NAC program with you. And we have two great speakers who are alumni of that program that we will introduce shortly. But first, I just wanted to start by introducing myself. I'm Summer Ash. I'm the STEAM Education Manager for NRAO. And myself and my team are based in Socorro, New Mexico. So there also might be some network issues, hopefully not. We usually don't experience them, but just wanted to warn you that Socorro is not known for high-speed internet. If my team could go ahead and turn on their cameras, Faith, Tyler, and Montana. And Faith, you want to introduce yourself?
Hi, everybody. I am the education specialist here. My name's Faith Vowler. And so Summer and I are on the education team here in Socorro.
And then we have two fantastic tour guides. Tyler.
Hi, my name's Tyler. I'm a grad student at NRAO here in Socorro, and I study pulsars.
And Montana.
Hi, my name is Montana. I'm a tour guide and a physics graduate student here in Socorro, New Mexico, and I study cute radio stars.
Fantastic. So Tyler and Montana will be primarily monitoring the chat and the Q&A. Please remember to submit any questions you have in the Q&A function. Faith will reiterate that in a second. And definitely, if you have things to say in the chat, make sure you set it to panelists and attendees. So Faith, if you could reshare your slides, and we'll see you guys later. Thanks. And then if you'll just go two slides in, next one. Thank you. So before we start today, everyone, I just wanted to acknowledge that today is June 19th, also known as Juneteenth. And on this day in 1865, the enslaved African Americans were notified of their freedom by Union troops in Galveston Bay, Texas, 2 years after the Emancipation Proclamation was issued. And so this day has long been celebrated in the African American community, but it's a history that has been marginalized a bit and until recently was not largely known to the wider public. And as you may have heard, in the past week, it has now officially been declared a federal holiday. Next slide, please. So I just wanted to let you know that we here at NRAO are acknowledging and honoring, sorry for my misspelling, Juneteenth today by highlighting and amplifying some voices from our National Astronomy Consortium program. And the NAC program is intended to increase the number of underrepresented minority students and women entering and remaining in the STEM fields, and specifically the fields that support the field of astronomy, EPO, science, engineering, computing, etc., by providing research experiences, long-term mentoring, and cohort support. So our two guest speakers today will tell you lots more about their experiences in the NAC program in just a bit, but now I'm going to hand it off to Faith, who will give you an introduction to the very large array for which everyone here on both sides of this webinar is here for. Take it away, Faith.
Thanks, Summer. All right, so first we're just going to take care of a few bits of housekeeping here. So the webinar is going to be about an hour. And if you have any questions that for us, please use the Zoom Q&A feature for that, which you can find down here. So if you put the questions in the chat, it's a lot less likely that we'll be able to see them and answer them. And some of the questions that you put in the Q&A will be typing out answers to, and then others will be answering during a live Q&A later on in this webinar. And you can use the chat feature to talk with your fellow attendees, make comments. If there's some kind of technical difficulties that we're having, please use the chat to let us know about that too. And make sure that your messages go to all panelists and attendees so that other attendees can see. That way, if there are some kind of technical difficulties, then other attendees will see, yes, others are having it too. It's not just me. We're also going to be using the chat occasionally to post links to websites where you can get more information about what we do and some of our programs. And you're welcome to click on them from the chat as well. But also all of these website links will be sent in a post-tour email. So if you don't get the chance to click on them while you're in the chat, don't worry, you will still be able to access them. And we will try to answer as many of the questions as we can, but depending on how many we get, we may or may not be able to answer all of them. And so if your question isn't answered, or if you think of a question later that you want to ask after the tour, you can go to our Ask an Astronomer page. And we have a whole set of archives of questions that have been asked in the past. So you can look through our archives and see if your question has been answered. And then if it hasn't, then you can ask a new question. Just submit your own question. And typically the answers to those are posted within 72 hours or less of when the question's asked. And so you're going to get to meet our guest speakers later, but they are Adria Peterkin and Aaliyah Wolford, and they are both NAC alumni. So Adria was in the 2015 NAC program, and Aaliyah was in the program for both 2016 and 2017. And so you'll get to, each of them will individually give a presentation about their experiences, and then we'll all come together for the Q&A where they can ask and answer any of your questions that you may have about their experiences. All right, so now moving on to just a brief overview of NRAO and the Very Large Array. So NRAO was founded in the 1956. And the goal was to design and build and operate and maintain state-of-the-art radio telescopes. And we study the radio light, which is a type of invisible light that our eyes are not able to see that come to us from space. And we have 3 major observatories: the Very Large Array, the Very Long Baseline Array, and the Atacama Large Millimeter Submillimeter Array. So the VLA is primarily what we're going to be focusing on today. And that was the main telescope that both of our NAC guest speakers today have used in their research projects. And we're funded by the National Science Foundation, NSF. So a small portion of your tax dollars, but to us very important portion of your tax dollars goes towards paying for our observatory and the work that we do. So that's why we think it's really important to be able to have visitors to our sites, either in person, or when we're not able to do that, at least do virtual tours. So of the 3 telescopes that we operate, like I said, we'll be talking about the VLA. And so the VLA consists of technically 28 antennas, but we're using 27 at any given time. And each of them are about 90 feet tall, and the dishes are 82 feet or 25 meters in diameter. And we're at a latitude of about 34 degrees north. And so that lets us see about 72% of the objects in our sky, which is pretty good. And that just means that the remaining 28% are too far south for us to see. And we're the VLA is located on the plains of San Agustin, which is an ancient lake bed in the deserts of New Mexico. We started building it in the 1970s, and then we completed and dedicated it on October 10th, 1980. And we chose this particular location because it's what we call high and dry. So when we build telescopes here on Earth, we want them to be at relatively high elevations, because the air in our atmosphere will bend or distort the light that comes to us from space. And so if we're at a higher elevation where the air is a little bit thinner, we can lessen that problem. And so the VLA is at about 7,000 feet, or about 2,150 meters above sea level. And we also try to choose a dry location because moisture or humidity in the air can also further distort that light that comes to us from space. So by being in the desert where the air is a lot drier, we can also lessen that problem. And one other additional nice feature that these planes have is you can see in the picture here, these mountains off in the distance. So the VLA has these mountains in most directions from these planes, and that serves as a way to block the interference that would come from Wi-Fi and things like cell phones and radio stations from larger cities. So this device is more than powerful enough that it would be able to detect such signals coming from cities like Albuquerque and Santa Fe and Las Cruces. So by having these mountain chains here, that serves as a natural shielding from that interference. And we have, we operate the antennas and the very large array on site from our control building. And like I said, we have 28 dishes, but at any given time, we typically have one that's undergoing maintenance over in our antenna barn. So that's why we have 27 that are up and running as part of the array at any given point. And the dishes are arranged in a Y shape, which we'll talk more about in a moment, as you can see in this picture here. So the VLA is made up of 3 sets of railroad tracks. We have the west and the east arms, which are made up of 13 miles of double railroad tracks. And with the north arm, it's 11 miles. Way up at the end of where the north arm would be, there is a ravine that would have been really expensive to build a bridge over. So rather than doing that, we just shortened that arm a little bit to 11 miles. And we have 72 different stations along these railroad tracks where we can put these antennas. In a perfect world, we would have 72 antennas, have one at each station, and that would be great. But money-wise, we were only able to afford to build the 28 that we have. So what we do instead is we arrange those antennas closer together or further apart to allow us to zoom out or zoom in. So we have 4 different major configurations that we arrange these antennas in. We very creatively named them A, B, C, and D. And in the A configuration, where the antennas are a long way away from each other, that has a diameter. If you were to draw a circle around the outer edges of the antennas, the diameter is 22 miles or 36 kilometers in diameter. So this is the configuration where we're the most zoomed in. So we have the highest resolution or the finest detail of the objects that we're looking at. We have the B configuration, which is 7 miles or about 11 kilometers in diameter. The C configuration, which is 2 miles in diameter, about 3.5 kilometers. And the D configuration, where the antennas are darn close together. And so this has a 1 kilometer or about 0.6 mile diameter. This is when we're the most zoomed out, so the VLA can see larger structures of the objects that we're looking at in the sky. And this just shows you what the configurations would look like as viewed from above if you were to draw those circles around them. So this little guy in here is the D configuration. Then you have C and B and A. We go in backwards alphabetical order between our configurations. So from smallest to largest. So we go D to C to B to A, and then back down to D. And so this shows you the differences between the objects that we can see in these different configurations. So oftentimes astronomers like to use as many different configurations as possible to look at the same object, because you can see different things when you look at the same object with different configurations, more detail versus these larger structures, as I mentioned before. So for who can use the VLA, anybody can use it from any country. And so the VLA is, again, since we're government funded, but you don't have to pay money to use it regardless of where you're from. If you want to use the VLA, what you have to do is submit a proposal that says, this is what I want to look at, and this is how it will benefit the scientific community. And we have panels of astronomers who will look at these different proposals and prioritize them based on like how much time they're asking for, but especially like the merit of the project, and then grant a certain amount of time. And from there, you might be granted all the time you ask for, you might be granted less time, or if your proposal is rated lower, you might not get to use the VLA this time, but you might be able to rewrite and resubmit your proposal, and then you might be granted time at the next time around. And so typically when you're writing a proposal, you're asking to use a certain configuration or sometimes multiple configurations. And so let's say that you've been given observing time on the VLA. What you do from there is you write a script that tells the antennas what to do during your observation, and it's sent to the operator, who puts it in the queue or collection of all the different scripts. When it's time for your observation to begin, it will pop up and start talking to the antennas, and they'll turn and look at your objects. And the data from each of these antennas comes to the correlator, or the supercomputer, and the correlator takes the data from all the different antennas, combines it together so that they're acting like one very large antenna. And so then once you get the data from your observation, you have 1 year where it's proprietary or private to just you and the people who are on the project with you. You can use that time to make images like these and write papers and plan further research. And you can continue to do all of those things after a year, but 1 year after the project is complete, the data becomes public. It goes into our public archives where anybody could access it. So let's say that I had submitted a proposal to observe with the VLA, and my proposal was ranked fairly low and I wasn't given time to use the telescope. What I could do instead is go into our public archives and see if there was at least a similar project done and use that data instead. Or alternatively, if I had a project that I wanted to do and someone had already observed the exact objects that I wanted to observe, I might not need to even bother submitting a proposal at all. I could just go straight to the archives and get the data and not have to wait for the whole process of writing a proposal. So now we're going to move to our guest speakers. This was just a brief introduction, so you have a little bit of background about the VLA for when we're talking about it, but I will stop sharing and we'll bring everybody else back.
Thanks, Faith. Adria, if you would like to turn on your camera and prepare to screen share, I will just tell everybody a little bit about you. Adria Peterkin is a nuclear engineer for General Electric, Hitachi Nuclear Engineering. And she is also an alum of the National Astronomy Consortium and National and International Non-Traditional Exchange, NINE, which is another program that we run here at NRAO. And during her time at NRAO, her work was focused on constructing a NASA Radio Jove receiver and telescope, something that you will see and you can actually do yourself at home. And she used that to observe and analyze Jupiter and sun emissions. And while here, she also had the opportunity to give tours at the VLA and to actually go inside one of the telescopes, which is a very unique experience. So Adria, welcome and take it away.
Hi, everyone. Thank you for taking the time to join today. So actually, I am going to actually also ask Aaliyah to join as well, because it will be a joint presentation with us.
Oh, yes, by all means.
Hi, guys.
Let me tell you a little bit about Aaliyah then. I had that prepared, but I had it sequentially. And so Aaliyah Wolford is a second-year atmospheric science master's candidate at Howard University, which is in Washington, D.C., nearby where I grew up. And I believe, Adria, did you go there as well or no? That's what I thought. Yeah.
Sure did.
Aaliyah's research interests are in astrobiology, atmospheric modeling, and paleoclimatology. That sounds complex. And she received her BS in biology and education from Elizabeth City State University. She also had a post-bac research scientist stint at NASA Goddard Space Flight Center, and she is a member of the NAC Consortium and a two-time AAS, which is the Astronomical American Astronomical Society, our professional organization, Chambliss Astronomy Achievement Student Honorable Mention Award. And she has accepted an offer recently, congratulations, of admission to George Mason University's Climate Dynamics PhD program, which she will be starting this fall. All right, now you can both take it away.
Thank you for that. I will go ahead and share my screen.
Okay.
And give me 1 second. Okay. And just, can you see my screen?
Yes.
Okay, perfect. Okay.
Excellent.
Hi, everyone. Thank you again for joining. Today, we will talk about the National Astronomy Consortium, which we just call NAC, and also the National and International Non-Traditional Exchange Program, which we just shortened to the NINE program. So this talk will be between me and Aaliyah. And yeah, we'd like to just share our experience with you all. So here we go.
Okay, guys, so as you know, this is the NAC as well as the NINE. So as you know, NAC is led by the National Radio Astronomy Observatory as well as the Associated Universities Incorporated, or AUI, and it is in partnership with the National Society of Black Physicists, or the NSBP, as well as they have other partner organizations. NAC's primary mission, of course, as we know, is to basically increase the number of students in underrepresented minority backgrounds in STEM, and that we are here to basically to support and facilitate and to break down barriers for students in of all backgrounds, races, and creeds.
And along with that, so my internship was mostly focused with NAC and NINE jointly. So the NINE program mostly focuses on radio astronomy. So we, and this is what I'll get into later, we focus on building, like using hands-on experience to build NASA Radio Jove. And we use that to learn about basically radio astronomy and also apply what we learn about project management and systems engineering to be able to do that. So you develop both skill sets to be able to understand astronomy. So the program, both of the programs actually provide just a summer research internship and also lifelong mentorship, and also a workshop in DC every year. And it's a lot more, but these are just some of the things we wanted to highlight that were really important.
Definitely.
So next slide.
So each year, the NAC has a cohort of students. So each year is referred to as a cohort. Students apply, and then they are placed with a mentor, and then they are sent to any one of these research sites as far as the NAC goes, and they are placed with that mentor for the summer. These are the following NAC sites that we have. For me specifically, I have been to Charlottesville, and then currently I am now in cohort 9, which is the new cohort, and I'm now at Space Telescope for this year. So these are all of the NAC sites, and then now Adria is going to talk about the 9 sites.
Yeah, so actually when I did my NAC 9 program, I was in Socorro, New Mexico, which is absolutely beautiful. But I also had a counterpart in Charlottesville, Virginia. And so the 9 site, the 9 is a little different just because it's also international as well. They have students come from South Africa, and they have a site in South Africa as well where they just ran the program. And it's also international as well as national. So it just depends on where you get placed once you're accepted in the program.
Mm-hmm. And these sites also, they cover a stipend for the students. You receive weekly NAC meetings. You get some perks of as far as like if you are applying to graduate school. I know for some of our mentors, they help us to sort of shape out our path for where we want to go forward beyond after. And those are just some of the things that from the NAC and 9 programs that they help us to do. So moving forward after we go from the summer.
Yep.
Mm-hmm. Okay. So this slide is very fun for us because every year because our motto is once you're a NAC or a 9 student, you're always a NAC or 9 student, that we every year, as a fun thing for us, is that after each cohort, we always have a NAC meeting. This is actually from last year's NAC meeting, which was nicknamed NACtober. Of course, with the pandemic and everything, we're not able to meet in person, but we got together and we had a month-long adventure together. So this is last year's. And what we did is that we had basically a series of meetings over the course of October. And we had different speakers come in, and we had all of the alums from years past. So the NAC has been going on since 2013. And so our NAC alums from all the way back then have come back, and we all get together. So you see Moya, you can see Tierra, you see Antonio, shouts out to you guys. You can see Jessica Harris. Just everybody's really just here. And it's just always really fun to get together. And we, as you can see, you see Tuesday here with her iguana. we have very, very fun times together. So it's not just all about science. So we have a lot of really interesting and fun times together. It's just really about fellowshipping and just getting together with our cohorts. So that's something that's really special to the NAC.
Absolutely. And just to piggyback off of that as well, during my experience with NAC 9 program, we did a lot of team building with the cohort, which we had a lot of fun doing. So one of the things we did did whitewater rafting down the Rio Grande. We did a mini camping trip. We went through Santa Fe and just walked around the square. And this is all just with a combination of not just NAC students, but also just other interns that are at the lab as well. And it really is an enjoyable experience to kind of be able to build that relationship with people from so many different universities all over. And then these relationships you build kind of follow you, and they become a part of your network moving forward as you build your career. And that's something that's just really important. And I appreciate it about my experience. So it helps make it fun. Okay, so just a little bit more about me. So I started my undergraduate at Howard University in 2012. 2015 is when I actually went through the NAC program, NAC 9 program. I graduated from Howard University in 2017 with my bachelor's degree in chemical engineering. And then from there, I went on to study at UC Berkeley, where I graduated with my master's degree in nuclear engineering. And from there, I started working as a nuclear engineer at General Electric Hitachi. And so that's where I currently am. And in the fall, I will actually be going back to grad school. So, yeah. And so just to talk a little bit about my project and what I did while I was a NAC 9 intern. So we focused on building a NASA Radio Jove receiver and telescope, really antenna. And so step one, we studied the principles of project management and systems engineering. This was really important because my advisor, her name was Lori Wingate and Demian Arencibia, he was from Chile. It was very important to kind of just understand our background in what project management was and what systems engineering was, which is a completely different field for when you're purely studying engineering. But it helps put the project into perspective. And the good thing about this is that it kind of helped guide the way we built this. So step two was to methodically construct our Radio Jove receiver. And I will show you pictures about this next. So building this, we had to use some of the principles that we learned from project management systems and systems engineering, just making sure that we're going through, we're validating our design, we're verifying all of the results and where we are with it. And so we did this by just understanding the different parts and their functions, a bunch of different capacitors, resistors, because you have a blank circuit board and you're soldering a lot of these onto it to help put the receiver together. And then using proper soldering techniques to do so. So then step two, we're testing our receiver. We're making sure that everything was put together correctly and it actually works. It turns on, we can receive emissions from it. And then we are setting up the antennas to be able to receive these emissions. So what we did for that is we actually first tested at Socorro, and then we also went to the Green Bank site in West Virginia to test. Unfortunately, at this time though, like Jupiter was in conjunction with the sun, so we were getting a lot of different solar flares that wasn't Jupiter emissions, but it was still pretty cool to be able to listen and analyze the results of our findings, which is step 4. And just to be able to present and understand what we were hearing and what we were listening to. This was about 21.5 megahertz, I believe, was the frequency of our receiver. So that's where we were. And then here's just some pictures from the build. So like I said, we started off with a blank circuit board, and then basically this is just constructing putting all the pieces together for the receiver to come together. I don't have any pictures of when we actually put up the antennas at the different sites, but there are these like huge poles that you have to put up in specific places to make sure that we're receiving emissions the way we need to. And so also from that experience, we gave a lot of tours at the VLA, which I really enjoyed. And so these are just some, we did like a weekend tour at the VLA. And then so this is some of the things that I really enjoyed. And I would like to show a quick video on kind of just like being able to climb inside of the antenna, the bowl. And so I'm going to put that on the screen really quickly. Actually, might need to stop sharing my screen to do so. 1 second. Okay. Sorry, 1 second. Oh, here it is. Okay. So that was one of the videos from being inside of the bowl. And the next video I'd like to show is when we were walking up to that point. And so that is here. And this is just to give a little bit more perspective on what it's like to kind of just be out there and to be involved with what's going on and giving tours. So I really enjoy that, and I wanted to share that. And so from there, I would like to pass it off to Aaliyah. Thank you.
Hey guys, so I'm Aaliyah. So I guess you could say my journey into astronomy was not very the traditional path, I should say. So from the beginning, I went to undergraduate at Elizabeth City State University as a physics major. It's a small HBCU on the coast in North Carolina. Back in 2013, unfortunately, my school was under attack with a lot of financial issues, and unfortunately, my physics program was shut down. So in that, I had to switch into biology, and that was, one of the best things that I could have done because it made my journey so much more. It made such a difference. But in between that, me being a biology major, I still wanted to do astronomy. So I ended up coming to UVA back in 2015, and I ended up connecting with NRAO, and they had gave me a tour of the facility. And then the following summer, the program said, oh, we have astronomy internships. And they knew that I wanted to apply. So I immediately ran to apply, and I got in. So summer 2016 and 2017, I ended up coming and becoming a part of the NAC family. And I did both of my internships at NRAO in Charlottesville. And that was like a game changer. It was so much fun. I got to meet everybody. Some of my best friends are in the NAC. And then from there, from 2017, I graduated from Elizabeth City State University. And that also in that summer, my mentor at the time, I should backtrack. My mentor at the time, Jackie Valedson, she had a collaboration at NASA Goddard. And so the project that we had been working, which I'm going to talk more about, we went up there and we had did a presentation on the project. And she knew I had an interest in, exoplanets and astrobiology. And lo and behold, Goddard actually had an astrobiology sector, and they had seen the presentation, and they were like, "Hey, let's have lunch." And I was like, "Sure." And we got to talking that day, and they were like, "Are you going to graduate school? What are you doing?" And I was like, I have no idea. So ended up, they were like, "Well, if you change your mind, we have a position." And it turned out I didn't end up going to graduate school, and I was like, "Hi, is that option still open?" And in 2018, I was working as a research scientist at Goddard. And I started working at NASA Goddard in the astrobiology sector, which was like my dream from a child. So I was like, dream check marked, bucket list met, everything. So I worked there. It was the best time. I enjoyed it so much. And then I knew that I wanted to go back to school. So I still wanted to get my PhD. So I did my research there. And then I ended up applying to go to Howard. And now I'm working on my atmospheric sciences master's at Howard University. And I will be finishing that in roughly about a few weeks. And in that, I also applied to my PhD program at George Mason, where I will be then going to climate dynamics and concentrating in paleoclimatology and atmospheric modeling, and just, all the things that I just really wanted to do. So without the NAC, all of my research interests and dreams would have never have came true had I not connected with this. So you can go on to the next thing. So the project that I used, that I did while I was at the NAC in 2017, was looking at radio observations of indoor space weather. And specifically, we were looking at Wolf 359, or C in Leo, which is a red dwarf. And that the big picture of this project is that we're trying to see how flare activity impacts planets. And so this project was actually a multi-wavelength assessment. So that was what I said, that this was a collaboration with other collaborators at NASA. So we were specifically tasked with the radio data, but we also had people assessing the X-ray, the optical, as well as the X-ray, and the optical data. And so what we were trying to do was that we were specifically looking at if we could detect certain types of emissions in that data. And when the reason why this is a big deal is because when you're thinking about that flare activity and how it impacts planets, flares can be very detrimental to atmospheres. So as you know, the planet on Earth, we have a magnetic field that protects us from all of the stellar, all the solar winds and that flare activity. But if you have a lot of it going on, then when we're thinking about exoplanets and they have that going on, you're not going to find those habitable ones, or the ones that we're looking for, where you would find aliens. So for us, our project was that we were just simply looking to see what type of emission that it was going to be, that was being detected from the radio waves. So whether that be from gyrosynchrotron emission, which we know is synonymous with flares. And then if we looked at the lower wavelengths, you could also see the coronal mass ejections, which are also sometimes are succinct with flares. And you can go to the next slide. So the way that we did that, so my project was looking at the higher wavelengths. So we were looking at the 8 to 12 gigahertz, which is the X-band data. And we first had to process all of the observations. So there were a total of 8 observations through a pipeline, a CASA VLA pipeline. And this was just to sort of calibrate and to get rid of any of our noise or anything that was not, that we didn't need out of the data. And then we needed to image the data and remove some of the background sources that was in the actual data. And then we had to record the flux and the errors of each observation. And then from there, we then had to plot basically this brightness as well as the right and the left circular polarization, which is showing us the gyrosynchrotron emission. And then from there, we had to see what type of, from there, we had to plot the percentage. So the reason why I said what gyrosynchrotron emission is that gyrosynchrotron emission is synonymous with flares. And then you also have cyclotron maser emission. And cyclotron maser emission, which is what you see in, if you've ever heard of the Aurora Borealis. So if you had a type of circular polarization going on and it was with cyclotron maser, then that would mean that the star was producing auroras, which of course that's not necessarily harmful to a planet. So we were trying to see what type of emissions that this star flare activity was producing. So that's why we were looking at the emissions. And if you go to my next slide, you can actually see the images that I produced for CNLEA. So this is actually the observations that I put together into like a little flip so that you can see. So yeah, so I'll see if it'll let it run through again. Yeah, could you play it again? So right here, so this is when the star is not flaring, but as you can see, when at 5 right here, that's when the star is actually flaring. So this is actually where the images that I cleaned, and then you can actually see the flare of the star. Flare, and so that's it. So we knew from our project that we knew that we had flare activity occurring, and that from there, the bigger picture was that if we went and we looked in the lower frequency data that we had, which was like the 1 to 2 gigahertz data, we were hoping that we'd be able to detect the coronal mass ejection. And from that, if there is a coronal mass ejection, we know that if we were looking for exoplanets that were possibly around this star, hypothetically, possibly they would not be habitable, because if you have a lot of those occurring, that would mean that their magnetic fields or their atmospheres are no good. So that's what we were looking for.
Nice, fantastically. Yeah, that was great. So just to kind of close out, we wanted to talk a little bit about like how important this experience was for us. We felt like the NAC 9 program really helped each of us kind of build a career in STEM. So when they say lifelong mentorship, that is very important and that is very serious. I am still very close with my mentor, and I speak to her probably about every like month or so at this point. But she has helped me kind of like with my career, figuring out what are my next steps, for other internships that I've done, even just getting into grad school and beyond. So I think it's really important to have mentors in general, and to be able to develop that relationship through this program has been pivotal. And that's one of the things that I feel like people, that's one of the things that I feel like is underrated about this, how important that mentorship has been and how excellent it has been. And I just really appreciate that. The next thing I will say is that the work really will follow you. I still go into interviews today and get asked like, hey, what did you do at NRAO? Can you tell me a little bit more about like your Radio Joe project? Like I still get these questions and I love answering them at any point. It's still like, it gets me excited to think about it and still go back and like remember what I did. And I think that speaks to the quality of the work that NRAO and the NAC program has their students doing. And also just like, who doesn't like astronomy? Come on. So it's just really cool to be able to kind of bring that up and talk about and share your experience as you continue to go through different phases of your career. The next thing I would say is that it gives you the opportunity for professional development. And a lot of that is through the program. We had different like seminars, different meetings, where we just talked about like things like how to give a presentation, like going into grad school, what are some things that are important for you to know, how to prepare for the GRE. And a lot of this is really important because the idea is that, at least from an undergraduate, they want a lot of their students to be able to go to grad school, and how do we kind of like make sure that we have a path to do that. And then finally, there's plenty of networking opportunities. And that's through AAS conferences, that's through just your cohort, working with different people at NRAO. Like, there's a ton, and it's really important you build your network, and it really does follow you. So I would say that this program absolutely has helped me build a career in STEM and just make me feel confident about the work that I get a chance to do and the people that I have the opportunity to meet. And I think that's something that's really important, about a really important aspect of this program. What about you, Aaliyah?
Yeah, definitely, Adria. You definitely hit the nail on the head with that. Like, as far as like with mentorship, that is a very important. That's like what makes the NAC like shine. Like she said, I have a very close relationship with all of my mentors that I've met at the NAC, and that we still talk to this day. And that they really have made a real difference in who have shaped me into the person that I am today. That they're the person that makes me, you know, that I'm not just a scientist. And that was something that, like, as a mentor in the NAC, something that I really loved about my mentors is that what I loved about my mentors specifically is that this was the first program that ever that my mentor sat me down. And it wasn't like when they talked to me, they didn't just talk to me about science. They talked to me about life. They talked to me about professional development. They talked to me about mental health. They talked to me about, you know, that it's okay to take time to yourself. It's okay to have that work-life balance. And that, you know, because I feel like when we think about the STEM field, you know, and how, you know, that it's a very competitive field, and that, you know, that sometimes, like, I feel like in certain aspects, especially coming from biology, at times it can be kind of cutthroat. You know, in astronomy, my mentor was very much like, take time to yourself, have that work-life balance, make friends, you know, spend time and do things and have fun, you know, and, you know, just to sort of look beyond those things. So it was just like that. It was really, that's something that I really enjoyed about my mentor, and about just, you know, her teaching me, you know, just the, you know, work hard and play hard just the same. And that also that your work does follow you, definitely. Like, I still do get questions about the work that I do. One of the biggest things or blessings that I had the opportunity to do was that while I was doing the NAC program that summer in 2017, as part of my education's degree, is that I had to do an observation or a field. And so I had to do field training as a teacher in a high school, and I had to teach in Elizabeth City. And Elizabeth City specifically is it's a town for farmers. So a lot of the kids, they don't necessarily have a lot of experience with STEM. When I told them about astronomy, they thought I was talking about fortune telling, but it's okay. But so I remember for one of my classes, I got to pull up my summer research, this specific project I just told you about today. And they were like, wow, where do you do this? Wow, how do you do this? And I was like, yeah, it's right up the street in Virginia. And they were like, really? And so that was like one of the most rewarding things that I have ever had the opportunity to do, because it was like, you know, as a, you know, being able to teach kids who, you know, that really have never had this experience, especially kids who are minorities, who, you know, they didn't think that that was something that they could do, but just being able, just to know that maybe I might have inspired somebody to be able to think that they could do STEM and follow their dreams into something more is the most rewarding thing. And then just, you know, like she said, giving opportunities to learn about professional development is awesome. And that, you know, like for us, what I really liked was that we got to do, they can help with you like getting ready for the GRE. I remember during my specific time at NRAO, like if you were trying to do the physics GRE, which we all have our feelings about that, we had the luncheons at the astronomy building in Charlottesville. And we actually went through specific physics GRE tests, and, you know, they were helping with prep and, you know, things like that. And then the other thing that I really loved was that, even if that wasn't what you were trying to do as far as like doing the physics GRE, I love that NRAO was very helpful and the NAC was very helpful, that they're very adamant about what do you want to do, and that they're very adamant about helping to push you to where you want to go, whether that's into the physics department or into communications, and that they're just very adamant about making sure that you're able to reach your goals and to remove every obstacle that they can to get you to where you want to be. So that's something that's very rewarding, and that's a very big blessing that I've had the opportunity to witness as being a part of the NAC. And then, like she said, being able to go to the being a part of the networking opportunities, being able to be a part of the NSBP, being able to go to the NAC meetings, of course, going to AAS is always a fun thing. I think everybody that went to Honolulu I think that we all have had some good times there. So definitely a lot of fun times to be able to network and be able to just meet a lot of different scientists in different fields. So it's a lot of fun.
Okay, and
So, yeah.
Does anybody have questions? And
This has been
over to
amazing.
you, Summer.
Yep.
Thank you both so much for being here, for your time and energy today. That was so fantastic, and a lot of cool things to hear about, because we all have like such different experiences. There's so many different ways that you can become involved with NRAO and with radio astronomy.
Sure.
So we do have a couple questions in the chat, and one of them might require resharing some of the slides. But Aaliyah,
Yes.
what do the colors on your data in that flipogram represent?
So let me go back to the flipogram. Let me share the screen. Oh gosh.
It's okay, take your time. Yeah.
Okay. So the colors on the actual colors, where you're seeing like the blue background and things like that, that's not really a signal or anything like that. That's like where you don't really have a lot of emission or anything. So you don't really have anything there. But where you're seeing like your greens, your reds, and your yellows, and where you're seeing your actual your greens and your yellows, these are actually kind of what you call side lobes coming from the star. The actual star is actually right here, if you can see my cursor. So right here is the actual star. And then when you're seeing that flare, the actual flare is sort of creating these sort of side lobes that you're getting from the data. I'm sorry that the image keeps going away.
No, that's
so, yeah. So anything out here, this is not really anything, but where you're seeing right here in the center, this is the actual star. And then when the star is actually flaring, you have what's being produced as these side lobes, which is sort of like which is kind of, help me out here. It's kind of that sort of interference that's coming from the flare activity from
exactly.
the star.
Yeah, it's particular to radio astronomy.
Yeah.
Yeah. And so it's essentially like it's an intensity scale.
Yes.
So more radio emission here, less radio emission there.
Yes.
Fantastic. Adria, we have a question for you. Where is your Radio Jove installation now? Is it still
I still have my receiver, but I do not have the antennas. They were way too big to keep. But I still have the receiver actually.
So it was pretty much sort of developed and put to use and then disassembled.
Yeah, so the antennas were disassembled. They're really big and you have to set them up like very particularly in a certain place. Depending on where you set them up, the better your emissions are, the better like the signals you're receiving for them. So I haven't used the antenna since. I played with the receiver a little bit, but not much of them both together since I've tested it.
Yeah, that's fair. Faith, do you want to take the question in the Q&A?
Oh, sure. I think Tyler's providing an answer for it too, but so that everyone can see it. So are the words antenna and radio telescope interchangeable, since we seem to use them at different times? So basically, yeah, we use the words radio telescope and, sorry, I slipped away from my Zoom window here, radio telescope and antenna, both to refer to our dishes at the VLA in this presentation. But yeah, and obviously not all antennas are radio telescopes, because you've seen antennas being used for other things. So it's sort of like the radio telescopes do use antennas, but not all antennas are radio telescopes. But for the context of this presentation, yes, we we mean a radio telescope when we say an antenna. And with the VLA, at least in a lot of these arrays, the various antennas, like an antenna is an individual dish. And so the many antennas will work together to make one radio telescope, but you can also have a single dish radio telescope where it's just one antenna and that by itself operates as the telescope.
Yeah, excellent explanation. And fun fact, the very first NRAO telescope is a single dish telescope in Green Bank, West Virginia. So it is one 300-foot or 300, something ridiculously large. The very first one they built actually collapsed under its own weight. So they had to rebuild another one. And single dishes and interferometers or arrays like the VLA, they can observe some of the same things, but they actually kind of have their specialties. And there's things that the VLA can see and better observe that like Green Bank could not, and vice versa.
Looks like we got one more. So why do these dishes not have any side skirts? Is this because the mountains help shield radio interference? Yeah, so I don't, in terms of like not having side skirts, so the way that these dishes work is the light just hits the dish, and then the dishes are made in such a way so that the light from there bounces up to the subreflector at the top and then goes down into the receivers. So like with optical light, you don't want light coming in from the side to interfere like with what you're looking at. But with the way these dishes are built, like the side skirts, like that wouldn't really change the way that the dishes work with reflecting the light up to the subreflectors and down to the receivers. So sorry, I know that's not the best explanation of it, but it just has to do with the way the dishes are built to reflect the light.
And I think just to add to that, Faith, I know that I've seen some much smaller radio arrays where the telescopes are just a little bit taller than a human or maybe one or two humans. And so I don't know if those are side skirts, but sometimes there's like a shield that's around them. And it does kind of keep shielding from nearby, probably because the dishes are so much closer to the ground. So they're more likely to get that interference. And Faith and whoever asked was exactly right, that the mountains that surround the plains of St. Augustine sort of act like a side skirt for us, as does our just remoteness in general. So I wanted to, we have gotten a lot of questions now, so maybe we'll just go over by a few minutes. But Aaliyah, I wanted to ask you if what are you looking forward to most about being a part of cohort 9?
So the project that I'm working on currently is that I'm working with Dr. Arpita Roy. And so we're actually going to be looking at, we're going to be trying to see if we can see an exoplanet with reflective light. And I've never actually worked with optical data. And so or instrumentation. So that is like so cool, because for the most part, most of my projects have always been in atmospheric modeling. So I know what I'm looking for as far as like what to expect in models, but the idea of actually looking at exoplanet detection is like, I think that sort of gives me an idea of being able to sort of be better at modeling, because if you know what you're looking for in the real world, it makes you kind of a better model because you know what to expect. So it's kind of like, it just sort of works together. So that's what I'm really excited about.
Very cool. I think you also made or brought up a great point about astronomy and a lot of science in general, but specific to astronomy is a lot of times you have some people and their specialty is theoretical and modeling and simulations. And then you'll have the observers who are going out, getting the observations. You'll have the engineers and a cross between everyone of making the actual instruments that are then getting the data. And it's kind of iterating between all these groups as how you advance the field and advance the projects.
Yes, I like the fact that like, it's so fun to see that like now that like we're in such a time that like science is becoming so much more interdisciplinary and that everybody's working with everybody, because it's just like, I think now we're just that like we realize that there's just so much to learn from everyone. So we need each other, and it's just such a collaborative thing.
Well said.
Mhm.
Faith, do you see any good VLA questions to pull?
Well, there are a couple about the Jove project antennas. If so there's one like how are there parts and schematics available for building them? Like how, so I guess kind of like how did you build it? Like is there a list and schematics available, or what was the method that you used to build them?
Yeah, so there's a whole, like, it's a whole kit. There's a whole list of things that you have to kind of go through to be able to build it. So really, you first start off with your receiver. And so we took a different approach because our work was focused on systems engineering and project management. So with that, we kind of try to use some of those techniques to think through how we were going to start the build. So the first thing we did was kind of just read up on it just to make sure we understood what we were looking for, what we were doing. We started by going first with the receiver. And really it comes as like a blank circuit board first that you kind of have to just solder together. There are a bunch of pieces like resistors, capacitors, all these different pieces that you have to kind of like put together on this board and solder them correctly, because I mean, you have to get the signal to be able to transmit through it. So from there, we're kind of like putting the receiver box together so that in a way that one, you can tune the receiver to different frequencies, the sound, and also just connecting it to the circuit board to make sure that, I guess, you're actually getting sound and it's working correctly. And then from there, once you put the receiver together, then you actually have to go outside and set up your antennas, which, like I said, there are these huge poles that you have to set up, but there are instructions on how to kind of go about doing it. And so for my mentor, she had already done it a few times. So she was great at kind of just like giving me guidance on like how to place them, best practices for it, like what works. And so one of my mentors, Demian, I believe it was his first time as well. So we had a lot of fun kind of just trying to figure out like, does this work? Are we getting any sound from this? Like, and I think the harder part was just trying to figure out like, what exactly are we listening to? Like, what sounds are coming in? And at a certain point, we had to realize that Jupiter was in conjunction with the sun. So we weren't getting the emissions that we had expected to get, but we still had to interpret what we were getting. So there are kind of like instructions and kind of things you have to look up to figure out how to do that. But I believe Summer posted a link in the chat also. Just
I did, and I just reposted it and we'll include it in the post Zoom email that all attendees will get.
Perfect, yeah. But Radio Jove is something honestly anybody can do, and I encourage you all because it's a really cool project. And then it focuses more on the instrumentation. I personally am an engineer, so I like working with hands-on things. There are steps to be able to do it, and just instructions on on best practices and how to do it. So yeah.
Fantastic. I think maybe we'll take one more. Do you see one that you like there, Faith?
Sure. It's kind of related to that, but it was for the Jove antennas, like just as a follow-up, I think, can they be assembled and disassembled multiple times without breaking while moving to different locations?
Yeah, they absolutely can. They are big. You just have to be really careful with them. Like I said, I know for me, I was traveling a lot, so like flying wasn't exactly conducive to be able to carry them, but you can break them down and put them back together. You do just have to be careful with them, and it depends on your mode of transportation as well. I don't recommend flying with them, but if that's what you choose, then you can find a way.
See if TSA will let you get away with that.
Yeah.
So I think that's all we really have time for. We never get to all of the questions, but we really want to thank everyone for joining us. And I especially really want to thank Adria and Aaliyah for your amazing presentation and for your enthusiasm for radio astronomy. Woohoo! And for joining us today. It was really, really exciting to get to meet you both and to hear your stories.
Thank you for having us. This has been fun.
Thank you for having us. This is excellent. Mm-hmm.
All right,
I'm going to hand it back to Faith, who will just wrap it up and tell you a little bit about what's coming up next.
Yeah, so sorry, my screen doesn't seem to want to share properly. There we go. So So yeah, if you want to learn more about the VLA, I already posted a link to where you can watch videos similar to kind of what was shown earlier, where they Adria showed some videos that were filmed from on the dish of a VLA antenna. We've got more videos that are informational and explain more about the science behind them on our website. We have a couple of other website features that are shown here, so you can see our mission control that shows you what the VLA is currently looking at, and our webcam, which shows what the antennas are doing. That updates every 15 seconds, and so those are on our website as well. And next month, our tour is going to be on July 17th. It'll be at the same time, so 1 p.m. Mountain Daylight Time, and this one is going to focus on radio sky surveys and making maps of the radio sky. And so you can learn, that includes past projects and the current project that's going on right now called the VLA Sky Survey. So you can join us next month to learn more about that. And yes, thank you again to Adria and Aaliyah. We loved having you here. I hope everyone out there in the audience loved hearing about your experiences as well. And thank you very much, everybody, for joining us. We have a short survey that'll pop up when you close out of your Zoom window. So if you have a few minutes to answer that for us, the feedback would be really helpful. So thanks again, everybody.
Yes, thanks again. And hopefully we will see you again next month.
Thank you.
Bye.